Slack, and we'll get started. I want to try to give you guys as much opportunity as possible to practice this stuff. I'm going to try to keep the talky to a minimum today. Let's get started. So we'll take a look at this ERD domains README first, the ERD link there in Slack. So domain modeling. I don't want to spend too much time on this because you guys have already been kind of modeling your data for the previous two apps. But we just want to see what this would potentially look like with the relational database. So just as a kind of a recap, domain modeling allows us to outline the data values that we need to persist. And this is particularly important with relational databases because relational databases are not quite as flexible as Mongo, for example. So Mongo didn't even require a schema, if you recall. So it's very flexible. We can put data, different fields on different models kind of on the fly. But with relational databases, they're super powerful. And I think that they'll make a lot of sense to you guys. However, to truly get the most benefit from a relational database, you need to do a little bit more kind of pre-planning before you actually design kind of your schema for your database. And so that's why ERD diagramming is so important, even more so with the relational database. So again, it's just a way to kind of chart out your data. You can consider the attributes, the fields that you want on your data models. And again, ERD diagrams, the really kind of key thing is that it doesn't describe a solution to your app or to your problem. It just defines the structure of your data. And once you come up with an ERD diagram, you're certainly not married to it. We're going to talk about some strategies to, if you want to add a new table to your database, or if you want to update a field or a data type, or maybe you want to remove an entire field from a database. You certainly have, you can certainly be flexible and dynamic with relational databases. It's just not quite as simple as with a Mongo document-oriented NoSQL type database. So again, an ERD diagram, it just defines how the data is structured, but it's not necessarily supposed to answer or describe a solution to any particular problem. I want to put into Slack, I mentioned this yesterday, but we were a little tight on time. This is an internal app that we use at GA. Some of the instructors built this. And we use this for a couple of reasons. We use this for attendance tracking, for tracking of projects, for tracking students in particular cohorts and such. So this is just an example. You guys certainly, for your project, your Rails project, you'll probably only be required to have like 2, maybe 3 models or something. But I wanted to take a minute, take a look at this diagram that I put into Slack and see if you can, or somebody wants to come on mic, and looking at this ERD diagram, could you explain just some of the relationships that pop out to you? Like, what is this ERD diagram? How does it explain the data structure of this app called Garnet? And you guys should be pretty savvy at this stuff because you've done a great job at ERD diagramming for your previous apps. But if anybody just wants to come on mic and describe any of the relationships in this diagram, you don't have to do the whole thing. But
yeah, it sort of looks like the things in the center are sort of like the central, obviously they're in the center. They're sort of the central like containers of information. And then everything sort of branches out from that and connects. So, so it's all going to be based off of that information.
Yeah, so yeah, that's a really good observation. So what would be, again, this is just a diagram. It's not meant to like answer a question, but you can get a lot of information just by looking at this. So what would you suggest are maybe the most important entities for this application?
Yeah, obviously user membership and cohort are probably the most.
Yeah, for sure. So let me put in, and again, you guys should be pretty familiar with, with this. And this is kind of like, up to your discretion how you want to draw out your diagram, if you want to use some sort of software, if you want to do it like on the back of a napkin. But this relationship section kind of describes what these relationships are referring to. So in this Garnet example, let's take user. We'll just take a look at the user entity. So the user has some attributes of, username, name, email, password digest. So we know that there's some authentication involved, obviously. GitHub ID, and image URL. So if we look at this, it looks like a user, if we look at the very bottom of user, you have kind of a line going down and then like that crow's feet attached to membership. So it looks like a user has many memberships. So maybe maybe a user belongs to like a UXDI class and some evening front-end class, and maybe they took WDI, so they belong to like WDI as well. And you can see this relationship. We talked about this yesterday. So on the membership entity, there's that field user underscore ID. So would that represent a foreign key or a primary key on that membership entity?
Foreign.
Yeah, so why is it foreign? What does a foreign key kind of represent? What is the use for that?
To gather data from somewhere else.
Okay. Yeah, to take that a step further, what does anyone else want to elaborate on that that sentiment? Yeah, that's a very good explanation. We can probably take it a little further. So it is a way to gather data for sure. But I'd suggest if we take it a step further, it's also a way to designate how things are related, right? So every entity in here, if we looked under the hood in the database, they all have a primary key for themselves. So user has a primary key, probably an ID. Tag has a primary key of ID. Tagging has a primary key of ID. However, for this membership example, it has that foreign key field of user ID because it just makes more sense if a user has like 4 or 5 memberships. We don't necessarily want to put all the membership data on the user, right? It makes more sense to put that one user ID on the membership entity. It's just a cleaner way to establish these relationships. And this is almost completely the opposite of how we did stuff with Mongo, right? So with Mongo, we probably would have had our user document and then embedded memberships on the user. That's how we used Mongo in Unit 2 and 3. And while that's a really fast way to query information, if we were trying to build something like Garnet, the way this ERD diagram is structured, if we tried to build this in Mongo with embedded documents, you can imagine that would be, it would probably be super slow, and it would be like very, very deep with embedded documents within embedded documents and such. And of course, you can use Mongo with relationship. I think some of you guys actually use, instead of embedded documents, you use that references feature of Mongo. So you can certainly replicate a relational database paradigm in Mongo. However, at some point, you have to ask yourself, like, would this be easier if I just used a relational database if it's going to get that complex? But yeah, so in this ERD diagram, you see the straight lines and the crow's feet. So the crow's feet represent that a has many belongs to relationship. So for example, a user has many memberships that he or she belongs to. A user has many observations. A cohort's a really good one. So a cohort has many memberships, has many assignments, has many events. And then even a location down at the bottom right. So location has many cohorts, right? So maybe like the Atlanta location has a WDI cohort. We have a data science cohort, a UXDI cohort. So this is a really well thought out ERD diagram. And this is what, for funsies, we're going to do here in breakout rooms. Have you guys try to create like an Airbnb or an Amazon type type ERD diagram just to get some practice with setting up these relationships. But before we do that, a relational database, again, we have a little bit more flexibility with how we can set up our data. So I want to quickly just take a look, just to get you mindful of how you can set up your data, not only for exercise today, but for your apps going forward when you're using a relational database. And this is all in the documentation and such, but just want you guys to be mindful of this. So one type of relationship that we can set up in a relational database would be a one-to-one relationship. So for example, a country would have one capital city, right? And a capital city belongs to one country. So this usually denotes that one entity should be an attribute of the other. You could probably, this actually a one-to-one, that actually may be a good candidate. You could probably get away with like an embedded document type situation if you wanted to. But a one-to-one, an example would be a country has one capital city and vice versa. However, we still usually separate those entities for physical space considerations. So if you're going to have a lot of countries, a lot of capital cities, when you're using a relational database, it would still make sense to create a table for country and then a table for capital city. And usually in a one-to-one, since it's a one-to-one relationship, they both have a primary key, and it's kind of up to you if you want to put like the foreign key on capital city or the foreign key on country. Since you're just establishing one relationship, it really, you could go either way. But let me ask you guys this. If you're going to put a foreign key on either country or capital city, saying that one kind of belongs to the other, how would you guys set up this data? Would you guys put the foreign key on country or the foreign key on capital city? I'm just curious. How would you guys think about setting that up?
Foreign key on city.
So on your capital city table, you would have like a country underscore ID with like the number of the country that capital city belongs to?
Yeah.
Okay. Yeah, that would work.
It depends. What are your objective, or where you're planning to search data in the database?
Yeah, that's a good point, JJ. Whatever business logic or business need that you have, are you going to be searching country more frequently than capital city? Or does your app revolve around, doing more queries on capital city versus country? But physically, you could put the foreign key on either table, and it really, space-wise, wouldn't really make a difference. But you just have to think about how you want to structure your app. Is your app more country-focused or more capital city-focused? Yeah, it's a really good point. Let's take a look at one more. And this is a pretty common one. This is what we did yesterday with our books and authors app. And that's what we're going to revisit again this morning, do some more queries on that. But this is probably one of the most common relationships that you guys are going to work with. So a one-to-many relationship. An example would be an author has many books. And so this is pretty much what we walked through yesterday. So we have two tables. We have a books table and an authors table. They both have a primary key. However, to set up the relationship of an author, which book did an author write? If you take a look at the books table, we added that foreign key of author ID on the books. So that's how we would establish that relationship. So any book that we queried would have the ID of the author that it belongs to. This is a super common one. So if you think about, even if you just have a two model application, you probably have a user model because you need to log into the app. So if you had like user and recipes, right? So a user has many recipes. A recipe belongs to one user or something. Or you could set it up so where, maybe one recipe, different users favorite, a single recipe or something. But generally speaking, a one-to-many is probably going to be the most common relationship that you guys are going to use in your applications. So let's take a look at two more, then we'll hop into some breakouts. Getting a little bit more complex here. So this is a many-to-many relationship. So let's say that we have books and categories. And let's say that a book has many categories, right? Maybe you have like a romance, vampire, horror book, or a historical fiction, romantic book or something. So a book can have many categories. And then conversely, your historical fiction category may have like a ton of books that, belong to it. So how do we establish a relationship like that? Well, in this case, you guys have probably heard of something kind of generally referred to as a join table. I think we're going to take a look at this maybe this afternoon or tomorrow, an example of this type of relationship. But if you read here through the screenshot, consider if we wanted to add a categories table to our app with like fiction, nonfiction, sci-fi, romance, etc. Books can belong to many categories, and a given category may have many books, right? So because of this, it doesn't make sense to put a book ID column on categories, because that's going to be a ton of book IDs for any given category. And then conversely, it doesn't really make sense to put a category ID on books, because we may have multiple categories that a single book would belong to. So the way that we get around this, conundrum, if you will, is to create an additional table, sometimes referred to as a join table. And this table just stores the relationships between the two tables. There is no other business logic other than the foreign keys for the two tables that you're trying to join together and establish a relationship. So you can see that here in this diagram, for example. So we have books and categories, and then we have this categorizations table kind of in the middle. So category here we go. Can't even talk this morning. Jeez. Categorizations would have each row in this table would have its own ID. And then it would also have the book ID and the category ID for one, relationship. So if we had a book with an ID of 1, maybe that book with ID of 1 has the category of 1 also, which is like romance. And then the book 1 also has a category of 2, which represents, historical nonfiction or something, and so on and so forth. So you would potentially have this kind of middle table that would only contain pretty much, at a maximum, it would only contain 3 columns on it. It's just to join those two tables together. And quite frequently, we'll see this in some examples, this table is called categorizations, and that's totally cool. But a lot of times you would name this join table like books _ categories or categories _ books. Generally, the convention would be to name this join table, kind of join the two tables in the title that it's the relationships that it represents. But you could totally name it something different like categorizations as well. Cool. And then the final relationship, and we're going to walk through an example of this on Monday, kind of for a review before your project. But this is a really fun one, and this is actually the best practice for kind of designing your data. This is a has many through relationship. And so for this example, this comes straight from the Rails docs, this diagram and such. But consider that a physician has many patients, and it has many patients through an appointments model or appointments table. And consider that a patient also has many physicians through appointments as well. So unlike the previous example where we had a many-to-many and we just had this janky join table in the middle, a has many through, you would have a third table that would have much more business logic in addition to combining these two other tables. And you can see this in the diagram. So let's say that a physician has many patients, right? So maybe let's just say a dentist would have many patients. And maybe that physician, maybe that dentist actually practices at 2 or 3 different locations during the week or, particular times of the month or something. So we could potentially put other business logic on appointments. So if you look at the appointments table, so appointments has a primary key for the appointment itself, each instance of an appointment. It also captures the ID of the physician for that appointment. It also captures the foreign key for the patient for that appointment. And then it would also have other business logic, like the date of the appointment, maybe the location of the appointment, maybe if it's a new patient type appointment, maybe the reason for the visit or the appointment, like a tooth cleaning or, getting a crown put on or something. So unlike the previous example, a has many through is much more flexible because you can put more business logic kind of on that middle table. And then this also works the reverse way. So a patient has many physicians, right? You probably have a dentist, maybe like a general physician, maybe a podiatrist, other types of doctors, I don't even know. So a patient obviously would have many physicians. And so the reverse would be true. We could also attach those patients with the different physicians through this appointments table. And so we're going to take a look at this. This is a little bit more tricky. And this is something that we're going to spend Monday. Actually, we're going to build an app that's going to mimic this relationship. And this is really powerful because not only can we keep track of stuff, but we can also create new patients that are attached to a physician out of the box. We can also create new physicians that are attached to a patient out of the box. And we can do this all because of the magic of this thing called Active Record that we're going to look at this afternoon. So there's a lot of advantages to this type of structure. So I would suggest, as you guys are getting practice with this and modeling your ERDs, just keep in mind that the best practice, it's suggested that if you're going to do some sort of many-to-many relationship, like the diagram that I put above, the best practice would be to go ahead and instead of creating like a join table, maybe consider creating like a third, more proper business logic-y table model. And it's more flexible because if you scale up your application, maybe at some point down the road, there's more information that you'd want to store on this categorizations table, for example. More business logic, more fields or attributes or something. I don't know, maybe like, maybe you want to categorize by like year or so. Well, that'd probably go into categories, but in any event, if there's a way to create a many-to-many relationship with a third model with fully fledged business logic, that's kind of the preferred way to do it. And we'll take a look at that on Monday. Okay, so that was just kind of a overview of four, kind of probably the four most popular and most frequent relationships that you guys are going to use when you're designing your projects and your applications. I'll pause just for a second. I've been doing a lot of talking and I apologize. Do you have any questions about any of those relationships before we hop into a little bit of a lab time? And you guys can get some practice setting this stuff up. So right now we're just thinking about how we would think about and design the data, the business logic for our applications. And then, over the next 2 days, tomorrow and Monday and this afternoon, actually, we're going to see how we would code out these relationships using a relational database. So that's kind of where we're headed with this.
Hey, Mark, I have a quick question.
Sure, man.
Is there, do you have an example of when one would use a many-to-many as opposed to a many-through? It seems like a many-through kind of does what a many-to-many does, and then some.
Yeah, I think this is a decent example, like the books and categories. I'm sitting here racking my brain and trying to think of like other business logic I could put on categorizations. And honestly, like I can't think of one right now. So you don't want to like push in another model just to push it in, just to, make a has many through happen. However, if there's any potential way, or if you see there's any way that your app is going to scale, even in this physicians, appointments, patients model, if you take a look at appointments, it's still pretty basic. It still has the primary key for appointments, the foreign keys for physician and patients, but it just has one more attribute of appointment date. And that's really all you need to justify having a has many through. So if I could think of, maybe you guys can help me out. I'm totally spacing now when I think about categorizations. I'm trying to think of like one more field we could put on that to make it a has many through.
If you want a many to many, it would be patient and condition. One patient have multiple condition, and the condition has been suffered by multiple patients. So you have a many-to-many relationship there.
Yeah, that's true. You could probably add another. Yeah, you could do that, and then you would probably have a join table in the middle called, patients underscore conditions, and do something like that. Yeah, that's a really good example. So we could expand on the physician's patients appointments. Yeah, that'd be good. I just bring up the has many through because you can set up your data either way, but the documentation kind of suggests that it has many through. It just gives you more flexibility down the road. It's more scalable. So it's nice when you're planning out your data. If you already have that separate third model created, it just gives you more flexibility. Because sometimes down the road, if you realize down the road that you're going to need a third model, depending on how elaborate your data already is, sometimes it can be a little painful, like to just expand your database with a third model. However, if you do a little bit of pre-planning and foresight and try to think up that third model, it just gives you more flexibility down the road. And it accomplishes the same thing that a join table does. At a very, very base level, it just establishes the relationships between two other tables. But if you can add other fields and attributes to it, then it's just going to give you much more flexibility down the road. Yeah, JJ, you have some pretty dense experience with relational databases, right?
Kind of.
Do you have anything to add, or any other relationships that'd be kind of pertinent to know about right now that you professionally and such?
It depends on the business model. I have been working with different business model, and each one is have its characteristics, and all depend on. That's force you to think very well before start anything on the design of the structure and the relationship, because what you have to focus is how you are going to pull the information out. Then you design whatever you have to do, because you have to always think on performance.
Yeah, that's a really good point. Yeah, so like the earlier example that we had with country and capital city, a one-to-one relationship, it's still, you're going to put the foreign key on one or the other, but you have to ask yourself, is this app focused on countries, or is it more focused on like visiting capital cities or something? So, that's a really valid point. What are most of the queries going to be? Are they going to be on grabbing countries, and then the capital city is just kind of like a bonus? Or are you going to be looking primarily for capital cities, and the country is just kind of a bonus piece of information that you're going to have? That's awesome. So let's move back into, want to take like maybe 20 minutes and put you guys into breakout rooms and just have you guys practice with some ERD diagramming, just thinking through diagramming some of these apps that are listed into Slack. If there's some other app that you want to diagram, feel free, like Blue Apron or something. But I'll put you guys in the groups, and I know that some of you had some really cool ERD software that you used for your previous apps. Does anyone want to suggest like a really good, because I know that there's a lot of them out there. Does someone have a really user-friendly ERD kind of online piece of software that they use to diagram their stuff? I saw several really cool ones. Does someone want to put into Slack something they recommend? Creately? Okay. So if you guys want to pop those into Slack, so feel free, if you want to grab one of those, for sure, whatever you guys want to use, or if you want to just draw this on paper, that's totally cool too. If we were on campus, I'd have you guys draw on the desks. But so I'll put you guys in the breakout rooms and just pick one of these apps and think about the entities that these apps consist of: users, posts, photos, if photos are shared between news feeds on Facebook, just relationships, friends, I don't know, whatever you guys come up with. There's really no right or wrong answer, just getting some practice. So we'll take about 20 minutes. I'll put you guys into groups, and the deliverable will just look something like this. just pretty much what you guys did for your previous projects. Just come up with some sort of ERD. And I'd love to hear each group kind of explain how they thought about the business logic and diagramming their ERD. So let me create some breakout rooms. Are there any questions while I'm setting those up? Cool. Just give me one sec and I will create some rooms here. I see two Jasons. Jason, are you logged in twice? I'll put both Jasons in one room just to be sure. Oh, cool. So it worked out. So we've got groups of 3 for each room. And again, no right or wrong answers. Just get some practice, with thinking about the business logic and how you would design your ERDs. So it'll take about 20 minutes, and then we'll reconvene. So I'll see you guys shortly. I think Eric is frozen again.